Okay, one more topic. I couldn't leave the contingency tables without showing you this one more topic. And this is something we call the YULE effect, or the YULE paradox, or very often called the Simpson's paradox. And that's because Simpson wrote about this 50 years after YULE. So it makes sense that we call it the Simpson paradox. Okay, so what is this Simpson's paradox? Well, okay, I'll show you by example. And this is really a manifestation of something that you will recognize very quickly because you know the composition formula. Now, what they did is they did a study by looking at 1 in 6 women who were in the electoral roll. I'm sorry, they looked at 1 in 6 persons in the electoral roll between 1972 and 1974 in Wickham in the UK. But I'm only going to report on the women because I'm telling you what was in this article here. Now, what they did is they classified each woman as a smoker or a non-smoker, and they came back 20 years later. They did a 20-year follow-up and saw who had survived and who had passed away in those 20 years. And what they discovered was this. So amongst the smokers, there were 139 who had died and 443 who were still alive. Amongst the non-smokers, 230 died and 502 were still alive. So 230 dead, 502 alive. Now, if you do the divisions here, you see that the mortality rate amongst the smokers is about a quarter. It's 0.239. But the odd thing is, surprising thing is, that amongst the non-smokers, the mortality rate is 0.314. So it goes from about a quarter to about a third. What's going on here? This is very odd. Before you run off and buy yourself some cigarettes, let's look and see what's going on here. What we can do is let's look at them by age category. And if we look at the 18 to 24, we see that the mortality rate, there were 2 dead, 53 alive amongst the smokers. So the mortality rate is 0.036, whereas the mortality rate for the non-smokers is 0.016. Well, for the youngsters, it's not as good to be a smoker than to be a non-smoker. How about the 25 to 34? Well, here 0.024 is less than 0.032, so it's in the wrong direction. 35 to 44, 0.128 versus 0.058, so that's in the right direction. 45 to 54, 0.208 to 0.154, that too is in the right direction. I think I may have revealed my bias here. 55 to 64, 0.443 is higher than the 0.331. 65 to 74, 0.806 is higher than 0.783. And then in the last category, everybody died, and it happened in both groups. So that's equality. So what are we seeing here? We're seeing that in every single one of these age groups, except this one, in every single one of the age groups, the mortality rate is higher for the smokers versus the non-smokers. And yet, if you ignore the age classification, it's less. The mortality rate for smokers is less than the non-smokers. In fact, this is off by 1. If we had 1 more death there, if we had 4, then this too would have obeyed the same rule. But it doesn't matter. It doesn't matter. That's not the issue. The issue is this, even though every single category is in the one direction, the overall is in the other direction. What is going on here? Well, you've seen this before. You know it because you've studied the composition rule. And what it is that here we have it. Every time we look at this, we see that the yellows are bigger than the reds, except in this one. So what's going on? Well, let's look at the composition. Let's look at the proportion. Let's look at the weights. Remember, the mean is, and this is a mean, the mean hides a lot of sins, and the mean is made up of two things, the composition and the averages within the composition. So let's see what happens to the proportions. So this is 0.09, it's bigger than that, than the 0.08. 0.213, it's bigger than 0.214. 0.1873, it's bigger than this. 0.234, it's bigger than this. 0.1976, it's bigger than this. Here, it's in the other direction. This one is the bigger one. Here, this one is the bigger one. So when the mortality rates are low, then the smokers have bigger proportions in those. When the mortality rates are high, then the weights given non-smokers is bigger than those given to the smokers. So in other words, the non-smokers are older than the smokers, and that's all it is. So if you ignore the compositions, you're going to get misled as to the health effects of smoking. So you've seen this before. So what it is let me just draw for three categories. Remember, you had the three categories. You had the young, and the medium and the old, and you might have that for the young you might have an average there, for the medium there, and older you might have, these might be mortality rates. And then you know that you played around with the weights and that the average of these three is going to be somewhere in here, depending upon how much weight you gave to the younger ones. If you gave a lot of weight to the young ones, then you'd be down here, whereas if you gave a lot of weight to the older ones, you'd be up there somewhere. So whatever the weight, you might come up with a number like this, let's say. Now you can come up with another set of three, and this might look like this, where you've got that the three open circles are all above the solid circles, but you fiddle with the weights so that now the average of these has to be somewhere in here, but you can fiddle with the weights so that the average comes out to be here, let's say, below this one. I could have drawn this one a little bit higher, but it can fit in there below. That's all that's happening. The weights are what's telling us the story. The composition is the story. And remember, you should not compare the means of two groups if their compositions are different, because you might just be confounding all sorts of things together and blurring the issue at stake.